Hello and welcome to Yeyu Lab. Continuing our deep dive into the integration between open source LLMs and AutoGen, this new tutorial will show you the useful and popular feature function calling within the AutoGen framework that significantly extends the capability of agents using open source language models. Open source LLMs shine in their ability to process and generate human-like text at an affordable cost from local deployment or cheap API inference. However, when it comes to accessing real-time data or performing a fixed process to get an answer to a math problem, they hit a snag. The introduction of function calling of OpenAI's GPT models drastically extends GPT 3.5 and GPT-4 capabilities by enabling them to execute external API calls, which in turn allows access to real-time information and decision-making with contemporary data inputs. To compete with GPT models on this feature, some works are ongoing pushing the performance edge of function calling in open-source language models, including prompting strategies like the instance in LLMs and fine-tuning like what Fireworks AI did. In this tutorial, I'm going to keep developing multiple agents LLM applications in the AutoGen framework and using decent open source language models with function calls to see whether they can generate and execute a function task like calculation for currency exchange. I assume that you have already played with AutoGen for a while to create your own LLM-powered multi-agent conversation app. With AutoGen and its predefined conversable agents and patterns, developers can easily create an AI chat group crowded with different roles to handle complex generation tasks. However, AutoGen's low-level framework only supports OpenAI API. To use open-source language models, we should make their inferences compatible with the messaging to OpenAI API. To do that, there are a couple of tools that can help. One type of tool is like VLLM and Ollama, which construct the model inference locally with GPU support. And another type using API inference like Fireworks AI without local computational resource, but with a little token cost. In my last video, I showed integrate Fireworks AI's compatibility API into AutoGen, aligning with OpenAI APIs. No need for a dedicated handler. There are 5 steps to do that. Step 1, import packages with pipe install PyAutoGen. Step 2, define LLM config, setting the model from Fireworks AI. In order to use OpenAI compatible API, you have to adjust the base URL in the OpenAI object and add your Fireworks API key. Then set up the environment variable OAI config list. In step 4, you have to construct at least 2 agents, assistant agent and a mass user proxy agent. The last step is to initiate a conversation by prompting a math problem for a generation. The Q172 chat model exhibits impressive generation quality, a lower cost, and comparable inference speed to GPT models. Fireworks AI introduces a function calling model enabling AI to access APIs for real-time data and adaptive agent actions. Challenges like intent detection and data formatting are addressed by their fine-tuned Code Llama 34 billion model, which much outperforms prompt-engineered function calling solutions. Their released evaluation proves its accuracy, adaptability in multi-turn scenarios, and super intent understanding compared to GPT-4. The model name is FW Function Call 34BV0, and you can try it in the playground. Today, we are going to implement the function calling with this model to see whether the open source models can perform well in generating confirmed function calls in JSON format. Please note that the full support of OpenAI's function calling, not the function calling assistant, started from AutoGen's version 0.2.3, by providing decent decorators that wrap the function definition into JSON. Let's see how to call it. The first step, you should upgrade your AutoGen package if it's older than 0.2.3. Then you should create the LLM config object. We will create this object including what model to be used. In this case, we use the model from Fireworks AI platform. Make sure you input the entire path name for the model, the correct Fireworks API key from your account, and the base URL for the Fireworks endpoint. Step 3, as usual, you should create at least 2 agents. The creation of agents in this example is quite simple because we only define an LLM-powered agent chatbot and a user agent user proxy to execute the code from generated JSON formatted function calls. Here we don't have to write complex system message to the chatbot to guide its function parameter generation format. You only tell it to use functions to provide the answer. Step 4, here comes the most critical step to define what the functions and the parameters that we want the language model to call. This example firstly defines a help function exchange rate to return the exchange rate between US dollars and euro. It's a help function, so it will not appear in the function calling generation. Now we use Pydantic to modeling an object with currency and amount attributes to the class currency. It utilizes type annotations and field descriptions for validation. Now comes the newly released decorators of AutoGen. Here defines a currency calculator function decorated with user proxy, regest for execution, and chatbot regest for LLM for a currency exchange calculator. The function takes a base currency with an amount and symbol and a quote currency symbol. It calculates the exchange rate between the base and quote currencies and then returns the converted amount with the quote currency symbol. By adding the 2 decorators, the chat agent knows how to generate calls to respond to questions, and the agent user proxy knows how to pass the function object to execution. There will be a new section, tools, added to the LLM config after a successful definition of currency calculator, which shows a proper JSON format defining the function we want and following OpenAI's function calling structure. Now we should do some modification in the source code of AutoGen to make sure the prompting template in AutoGen are fully aligned with this language model. To now, the code works fine with GPT models, but unfortunately does not work well with FW function call 34BV0 model by throwing an error on name parameters in the message. Obviously, it comes from the incompatibility of this open source model with OpenAI models. But don't worry, I will show you how to make a workaround for it in a very simple way. Firstly, let's define a small function that deletes the name field from the tool call ID dict. Move this function to the top of the AutoGen source file, convertible_agent.py for a global definition. If you don't know where is the source file of AutoGen in your machine, type the pipe command to find its location. Pipe show PyAutoGen. Insert the del name function right ahead of this line of response generation. Under the function definition, def generate OAI reply. Okay, now we can start the conversation. Make sure you have successfully modified the source code and save. Then you can prompt the agents by input the message, how much is 112.23 euros in US dollars. With one shot, the chatbot agent was able to generate the correct function currency calculator with proper parameters, base object with euro for currency and 112.23 for amount and quote currency USD. After that, the user proxy agent executed the function and printed the result of 123.45 USD. The chatbot generated text to the user that 112.33 euros is approximately 123.45 US dollars, and then terminate the conversation. In conclusion, using the function calling feature with open source language models in AutoGen is possible when the model is specifically trained for handle function calling tasks and the message format of the prompt matches the model's definition. If not, you should make a modification on this messaging format to make it aligned. That's all for today. For the tutorial and the source code, you can find the link in the description below. Don't forget to like, subscribe, and hit the notification bell. Keep innovating, and I'll catch you in the next one.